Thank you. Thanks for coming down. I'm Mr. Zebra, and I'm currently hacking for Daft Code. I'm backend developer, and well, few people know that I make also delicious tuna paste. It's a joke. Today, I won't be talking about cooking, but making the king of snakes small. Yeah, that small. And to make things clear, it won't be presentation about shrinking reptiles or other things, but smallest Python implementation capable of running on microcontrollers. So let's go to my favorite question ever. Why? Why the hell do I need Python running on microcontroller? Well, why not? So a similar question could be asked about 25 years ago. Why the hell do we need another high-level programming language if we already have some? Well, in the field of microcontrollers, I could agree with you because Python is heavy, and if you are proud of running it on your old Pentium computer with 32 megabytes of RAM, well, good for you. But in the field of microcontrollers, it's too much resource to demand. And as you could see, you can program already standard CPython implementation on boards like Raspberry Pi or BeagleBoard, but those are pretty heavy machines. And if you want to build something simpler, like your first line follower robot or micro mouse, it's like this. It's too much complexity for a really simple task, and you don't really need that much of resources for this. So what you need is light interpreter. Luckily, some job was already done, and today I'd like to present you two approaches that makes my favorite programming language able to run on microcontroller. I mean, PyMite and MicroPython. But first, short brief about Python philosophy, because Python was created with great philosophy in mind. Good is better than perfect, because reaching perfection closes opportunities. And do one thing well, because tools should be created to solve problems, not to create new one. And stay open, let user tinker with the tool you create and let them extend it in the way they want. So this philosophy led Python creation. And if you want light interpreter of Python, it will be hard to preserve all those features that make Python great language, especially being dynamic, first class everything, maybe some implementation of data structures, and of course, because of dealing with completely different environment, standard library. So what to kick out and what to preserve? Let me begin with PyMite. PyMite is pretty interesting project, starting in year 2000 by Dean Hall. After 3 years of coding, he presented his work on PyCon without any great response from the audience because of lack of features and only 2 target implementation. Without any business plan in mind, he continued development until year 2011, when the project officially died as open source. What was left is incomplete Python 2.6 implementation, which can really give you some real Python flavor with classes, closures, and decorators. To make things clear, PyMite is only virtual machine and API for a microcontroller. There are about 10 platforms supported by PyMite, and what was left is also in-depth documentation for a language design, which can give you some sense about the design decisions. Let's continue with slimming Python for PyMite. Dean has a pretty brave idea in mind of creating a system able to run on 8-bit microcontroller, 8-bit architecture, with limited resources, 5 kilobytes of RAM and below 64 kilobytes of flash memory. There is no built-in compiler whole compilation happens on a PC, and compiled code objects are loaded on a board. PyMite is stackless to simplify memory management. Every object is allocated on a heap. Memory is managed by garbage collector, which is implemented with mark sweep algorithm. In my opinion, it's not the best choice because mark sweep algorithm, when you run out of memory, stops the whole system and performs memory investigation to find garbage objects. I mean, objects that aren't used. And PyMite doesn't prevent critical issues that could occur during the dead zone that appears during the garbage collector performing his work. There are also re-implemented data structures, mutable data structures. For example, lists are re-implemented as seg lists for simplicity. There are only pointers to object, to element front and back, and also segment size. And the design decision is also this, because using segments of the same size prevents memory fragmentation. The same structure was reused in dictionary implementation. So we have actually in dictionaries two lists, one for keys and one for values. So a little bit about PyMite features. As we can see, PyMite as being stackless, what is also tempting because of comparison to Tismer's stackless Python implementation. And indeed, PyMite supports green threads and also supports coroutines. Here we have simple coroutines that, well, prints everything it gets. It all happens with the yield statement with in parentheses. So we initialize coroutine, then start it with a next. We can see it's started correctly. Everything is print, and then every object sent to the coroutine is printed. So everything works fine. PyMite also supports multiple inheritance, but sadly, it's old method resolution order. It's in its historical roots implemented as depth-first search algorithm, so it creates the same issue as it used to. For example, here, when we have class A with save method defined, and subclasses B and C, where C overrides the A save method. So when we create class D inheriting from B and C, when we call the method A, the implementation from the class A is called. So this is a common issue with old method resolution order, which was resolved in newer implementation with L3 algorithm. PyMite doesn't cut off its roots, so it also supports native C function execution. It enables native C function calls with re-implemented docstrings, which of course no longer supports object introspection. There are also closures, but they are implemented in some strange way because here we have the simplest closure possible, generate and power, which sets a power index, and it wraps nth power method, which sets power base. So when we return closure and call it, it seems that it works correctly, but we cannot really investigate local scope of called functions, and we can't see them variables leaked in global scope. So, well, it seems like some implementation issue. No pain, no gain, they say, and well, programming in some small implementation of Python language wouldn't be possible without sacrificing some original CPython features. But actually, in case of PyMite, there is more pain that more of us would handle. For example, what pisses me off the most is REPL phase, and let me show you a little demo with it. Whoa, słychać? Cool. So we compile the PyMite REPL, and let's create the simplest possible dictionary with one key. And when we try to gently retrieve the value under, with a key 1, well, we get attribute error because the method wasn't implemented. So let's try in a standard way of REPL which attributes we can access with A. So no, it's not that dir method wasn't implemented, because it's only because REPL failed. It's broken because unhandled exception. So restart it, create similar dict, and then also nothing. So sadly, the current implementation of PyMite doesn't support any object introspection, and it's sad, really, because REPL could be the best feature of PyMite. For example, when you code on Arduino, you have to write code, then compile it, load it to the board, and then see or not an effect. When you have a REPL, you can get instant answers, so you catch bugs earlier, and whole programming is funnier, really. As I said, exceptions are already implemented. One of them you could see, but there is no way to handle them in current implementation. So yeah, that sucks. So restarting REPL over and over again makes the whole experience really frustrating. Also, you have to keep in mind hardware consideration. When you compile PyMite, you have to set heap size. And the good news is REPL needs only 2 kilobyte heap to perform well, but you can't really do anything about it because it's not even enough to print hello world. Or I'm not even saying about allocating space for class or even importing a line. So there are also some more missing features, like there is no set data structure, no long, no complex type. You can't subclass the built-in types, and built-in types are not callable. So, for example, you can't convert string 1, 2, 3 to an integer. It sucks, and it seems like we play with Python 2.6 syntax, but only with some pre-2.2 features. Programming Python maybe wouldn't be that hard if there were proper tutorials for this. We have about 10 platforms, let's say, supported, but none of the port is well documented. So if you have a problem with your board, you have to look in some old discussion in Stack Overflow. And well, it's sad because this project would be really charming. And I'd love to show you a demo with Arduino Mega, but I only was able to connect with a REPL on the board and print some basic integers, what's really a waste of time. But stay optimistic because there is a MicroPython, and MicroPython took the whole problem differently. Appeared about 1 year ago on with a really great result. The project was created by Damien George, PhD from University of Cambridge, and the Kickstarter success allowed him to build small business providing software and hardware for robotics hobbyists. The whole implementation, well, wasn't that radical. The goal was to implement Python 3.3 syntax able to run on 32-bit microcontroller, PyBoard, like this charm, which is its dedicated board. It's armed with 32-bit ARM microcontroller, about 200 kilobytes of RAM, and 1 megabyte of flash memory. What makes it complete hardware platform, it's built-in accelerometer and micro SD card board. Currently, PyBoard, it's the only board that fully supports MicroPython features. But the project, the same way as Arduino, is open source and open hardware, so you can make an effort and port it yourself. There are several ports prepared actually, for example, for Arduino. There is also, as I said, nice documentation, and there's community which provides tutorials to help you get your projects up and running. Let's continue with what makes MicroPython light. Standard library. As I said, standard library, original CPython standard library should be sacrificed for more gently, well, let's say, peripherals library. So we have PyB, but also OS, sys, CMath, and time. If you puzzled with OS package, well, because whole compilation happens on board, we have a parser implemented in MicroPython, compiler, virtual machine, runtime, and garbage collector. So it seems like it's complete Python-driven operating system on board. But, well, being light costs. So there are no meta classes, no descriptors, but the properties can be implemented in some workarounds. The same way in like PyMite, there is old method resolution order and mark sweep garbage collector. Well, to prevent dead zone, as I said before, MicroPython uses some tricks to balance memory usage, and there are two tricks of stack. With stack, I would like to tell you. First is stacked pointers. So the concept is easy. During accessing objects in object-oriented programming language costs, you have to access pointer, then add offset to reach current value of an object. For example, integer in original Python's implementation have some metadata included, but we can file with it with this trick of creating a 31-bit integer, which allows us to encode the integer value into a pointer. So with 1-bit shift and adding 1, we can encode integer value into a pointer. So least significant bit makes the distinction if we are playing with pointer or integer object. There is also escape analysis stolen from PyPy compiler. So we can allocate on stack objects which can live within the same stack frame. So compiler checks how long the object lives in the code, and for example, the reference of which objects keep the reference to it. Well, something more about MicroPython features. Basically, mostly complete implementation of Python free syntax, with also with will from statement, REPL, which works well. I will show you later. Well, if you miss some of original standard library packages, there is another project, MicroPython lib, which well, tries to re-implement common standard library packages in MicroPython. And also some functions optimizations. You can specify with decorators one of 4 types of code emitting. First is a standard way of executing bytecode in virtual machine. Next is native code, which converts bytecode to machine code. So C functions are directly called. There is also native code with native types called really cool, like Viper. and it forces 31-bit integer architecture and tagged pointers, and also inline assembler, which is interpreted as just a list of machine instructions. MicroPython is still work in progress. So Damien George doesn't want to implement whole Python. Well, mostly because not everything is assumed to be helpful in microcontroller programming. But trying to do one thing well, few things have to be fixed. For example, some semantical differences like this one. Range in for loop is optimized to while, so it's possible to overwrite the n argument within the loop, which prematurely ends it. It shouldn't happen in original implementation. Method resolution order, as I told you before, and some strange thing with accessing attributes with dir while subclassing built-in types. Well, time for a little demo, so. Cool. So we have a PyBoard here, and connect to a computer. Oh, and it appears as a standard flash drive. Oh, that's one. We can log into REPL with a picocom. And here it is. We have already we are able to execute code on a board. So, for example, yay! But let's play something serious. Import peripheral library. Create a LED object. And what we can do with LED. So let's turn it on. Yay! We can also turn it off. Or, more tricky, toggle. So, maybe something more advanced now. Let's program one of two available switches. Let's create a switch object. And when we call switch object, it returns false because it wasn't the button wasn't pushed. But if we push a button, we have true. Amazing. What we can do with with such switch? Callback. And this is pretty interesting thing because it's interrupt routine that runs asynchronously. So callback. We can load there every function we want, but let's begin with something basic. So, let's try this. Yay! So much fun. Well, if we are bored with it, we can allow, for example, LED to toggle. Oh, here it is. Like Christmas, yeah. So maybe we can use something more in the hardware we have. From the hardware we have, well, I've prepared some code for it. For example, spirit level, which is pretty basic implementation for LED driven with the angle of a board. Well, oh, thank you. Don't attack me, please. Oh, so now if we change the angle, we run. Oh, we accelerate different diode. Whoa. Do you see a difference? Thanks. But what we can do when we have some more hardware available. I've prepared the second board with soldered LCD screen. Well, let's try something with it. There it is. So, to log again. And maybe try with something more serious, like bouncing rectangle. If you want to see bouncing rectangle on a screen, this is the way to do it. Yeah. Looks like charm. But it's a presentation about snakes, so I've prepared also a small snake implementation, which is a game you can steer the whole thing with accelerometer. Why not? So here, well, this is everything that MicroPython is capable of. Well, maybe not everything, but the main concept is you can create a class with methods, simple inheritance, and the hardware usage. So, if you'd like to see the code, I'll upload it on to my GitHub today, so you can follow me. Happily, MicroPython supports micro SD card. So, if you want to well, refresh your memories with old cartridge style consoles, this is the way. So, card is loaded, then can restart the board. Oh, I was killed. Damn. Thank you very much. Well, basically, this is it. So to sum up, well, PyMite, well, even if quite charming and light project running on the 8-bit microcontroller is frustrating, incomplete implementation. But in terms of language design, it could be, well, really some funny playground for language designers. Well, if you want to build some hardware with Python, well, MicroPython is the way to do it. It has really nice documentation, good support, and nice tutorials. But on now only one board, and well, it's good to wait for some ports to make the hardware more accessible. I waited for mine till Monday this week, so so thanks, and if you have any questions, I'm ready to answer.
Hello. I've got a few questions. The first one is the SD card the only way for persistence of code on it?
No, actually, there is a file system on a board. I can show you with...
Okay, I don't need a demo.
Because
I can imagine a file system on... Yes.
There are two ways of boot the code in PyBoard. There is a main file on a board, which you can edit, and then after restarting, it's the main way to... is the first file that is executed. Okay, the second question is about real-time and the garbage collector, because you said there is a mark and sweep garbage collector. Yeah. Is there some kind of real-time mode that cannot be interrupted by anything? Or because, for example, if you build a robot with it, and the robot goes straight, and the garbage collector decides, well, it's time to check the memory, it would be a good idea to stop the garbage collector rather than wait for the robot to drive into a wall. Sadly, no. You have to wait 4 milliseconds for garbage collector to perform in MicroPython. Okay. Yeah. Thanks.
Okay, I have some questions too. First of all, do MicroPython support advanced feature of the microcontroller built in the board, like timers or... there are timer objects. Okay, and does it support some kind of callbacks on microcontroller interruptions?
For example, with buttons and for timers
for example, if I have timer and buffer overflow, or when receiving data from word on data received, or things like this. So you
can set callbacks. You can set callbacks on timer objects.
Okay. Yeah, that's it.
I think that MicroPython can't run only on one dedicated board, because I think that MicroPython can run, for example, on Teensy 3.1 board. My son did it.
Oh.
Yes.
That's impressive. But how about peripherals? Because, for example, I could run on my Linux system MicroPython 2, but
without gyroscope and so on.
I just wanted to know what is the goal of the project. I mean, what is the target of those boards? Is it a hobby project, or?
Well, really, it was started as a hobby project, because before Kickstarter, really MicroPython were implemented, but they needed support for boards, for starting whole production of boards.
Okay, because I was wondering if they have an ambition of competing with other languages that are used for the programming microcontrollers, like mostly C or assemblers or different kind of assemblers.
Well, I don't think it's a field to compete with C, but well, you can use just Python features to get things done easier.
Oh, okay.
Not faster.
Not faster, for sure. Yes.
Hi, sir. Does it have a USB hub, or what are the possibilities of interfacing it with other devices, some peripherals?
Well, I don't know about more devices than MicroPython produces. For example.
So only those that are on board, in fact.
Yeah.
I can answer that. This is a normal microcontroller board, so you can connect anything you would connect to an Arduino.
Based also in Python.
Yes.
So you can access also ports, and you can attach
Yeah, you have access with a peripheral library. You have access to direct pins.
Yeah. Okay. Thanks.
A small comment from. I also have MicroPython PyBoard, and I use it a bit. The 10C port is there. Some people can use it, although the 10C is very limited in space. So there is a problem with pushing code to it. STFM Discovery is another board. It's slightly cheaper than PyBoard. The port is almost complete, but not yet polished. And as for PyBoard, the microcontroller is supported. You have the I2C, serial, SPI, analog, digital, and so on. And lately, there are some projects that use that PyBoard MicroPython in some camera and something like projects on Kickstarter, something like that.
Okay, I've got another one. I've seen on the bottom of the board there was some test pads marked USB OTG. Is this feature already there, or is it like in the future? Did you try attaching anything to that?
Well, do you mean this? Or
PyBoard. If you take a simple PyBoard, on the bottom, I think there are 5 test pads in a pattern.
No, I haven't tried them.
Okay.
Yeah, for the most active users of my presentation, there are some prizes. So, could you help me? Thank you. Are there
any questions? Back for a question.
Question?
Yeah.
I have to come up with
lucky
something.
guy.
Oh yes.
If you don't want it, I can take it.
I don't know. Have you done anything more than bigger than like those squares and snake or whatever? Have you used this Python board to make a project of your own, which you applied to?
I'd love to, but as I said, I've been playing with it since Monday.
Okay. And the last question: how much does a board cost?
Well, board it's not the cheapest because it's about £30.
30. Oh, yeah.
Without shipping.
Okay. Thank you.
So, if I wanted to make my own board that also runs Python, for example, for one of the robots, but I need more pins to be there, are the designs already available, so I could take the designs and modify them? And
yeah, as I told, the project is open source and open hardware. So
sure, but many open source projects, they promise to publish after they finish. I'm asking if the designs are already published.
Well, as I know, they are published
Okay,
already.
great, thank you.
Come closer.
My question would be similar to the previous one about other project. We know you're waiting for your board on Monday, so you don't do anything right now. But have you heard about other people making some interesting project? Because for me, it's a little bit a bit hobbystic, and it's not any practical use okay, guy, I know something. Explain me something, because I'm also programming, and I use Arduino, I use Raspberry Pi. Even the price of MicroPython is similar to Raspberry Pi. Of course, it's smaller, and it's maybe used somewhat more. But for me, stripping the function of something from Python, it's too much for me. It's not worth it. So asking about some interesting project. And I know I'm gonna get answer soon, so thank you.
Well, actually, there's a community built around MicroPython and PyBoards. Well, as far as I know, there are some interesting projects, for example, using running, because you are able to run PyBoard as a human interface device. So it's well, it's used in this way too.
Can you give me just 1-2 example of interesting project? Something not more complex than Snake or something like this. It actually work on that board.
More than robots, snakes, and controllers for programs. No, I don't know anything about it.
Robots seems fine, but I'm not. Okay, I'm not. Actually, I'm not.
I think you're skeptical, but
yes, a bit skeptical, and actually, bit is a very easy word right now. But thank you.
Well, you're welcome.
Another question: since we can use micro SD card, what is the biggest size of script we can put on the SD that could be run by MicroPython without any serious delays?
For everything which fits directly addressable memory.
So we cannot use several scripts and switch between them on the run?
Well, switching between them, I don't know, but you can write a separate package that you can use within your script run in main file.
Okay, thank you.
You're welcome.
So we have time for last small question.
Well, the similar thing I was doing, I was completely nothing to do with microcontroller boards, was programming GPUs. You use GPUs in physics for computations because they have lots of computing power. And what we also do is Python to program GPUs, but we don't run Pythons on GPUs, but we generate code with Python, and the code is optimized with Python and generated and even manipulated symbolically with SymPy, and many pre-processing is done, and then we run it on GPU. What do you think maybe this way should be something like, if you have microcontroller, why nobody actually, I never heard everybody was generating code in some flexible way in a Python environment on some host, and then pushing in this code as a micro whatever is like Arduino C code to microcontrollers. What do you think about this way?
Well, this way is currently represented by 4 code emitters, so you can optimize within a function how it's executed. While converting it, for example, to native code, costs more RAM, but runs faster than original bytecode.
I think that I understood the question. Actually, I used Python as a preprocessor for C code, but it was very domain limited. I mean, I didn't even consider to write some kind of snippets that would cover all the functionalities of Python. But it was very simple, right?
Okay, so thank you.
Thanks.